Top 10 skills that every SQL developer should know. And some of these are secret skills. Some of these are things that you probably have never heard before, even if you've been doing this a long, long time. Some of these are things that are fundamental, elementary. And so if you've been doing it for a long time, you might roll your eyes a little bit because you already know this. But there's a pretty good chance that other people in the room don't. Has anyone ever noticed that there aren't enough people who have skills that we were? Right? Have you noticed that? Right? It's kind of like this evergreen problem that we have. In the consulting houses and the recruiters are constantly getting up and asking for people with skills. It's a structural thing. There have been 4% less DBAs every year since the Bureau of Labor and Statistics started to track these since forever, like the last 20 years. There haven't been enough DBAs. And so that's given rise in the SQL Server world to what we call the accidental DBA. That's where the CIO or the boss walks into the server room and says, "You're standing closest to the server. You are a new DBA." And you're like, "I'm just a visitor. I'm a guest. See my badge?" So my best-known book is this one, SQL in a Nutshell. Author or co-author on 11 others. I got my start in the mid-'80s, working for NASA, and I was really good at Fortran. Anyone else use those old languages, Fortran, COBOL? Yeah, representing from up east.
CL1.
CL1, all right, okay. So
that's 1, 2.
This is the old one. Still didn't have it. Yeah, so that was a lot of fun. Got to work with Fortran and SQL at the same time because it was before they had invented stored procedures. They didn't have any conditional code. So you'd write your if, then, else, and your variables in Fortran, and you'd wrap it around SQL and get it to do what you wanted to. And so we built the water recycling system in the International Space Station. We made 96% of the water that goes through a human body re-drinkable. It was delicious. Good stuff. Yeah, and so from there I wrote my first book. It was an Oracle book, and later I changed jobs. I lived in Huntsville, Alabama at the time, and then later after the Cold War ended, a couple of years later I moved to Nashville, Tennessee. They were opening a great big MIS center for Deloitte & Touche there, and I served 7 years there and was the manager of information architecture, and I led the data management team there. Before I went to Quest Software, maker of Toad. Anyone know Toad? Oh, yeah. All right, good product, So we built the SQL Server product line there, and then I went to SQL Sentry, who I believe now has the very best SQL Server tools. And not only do we have great tools, another thing I really like about the company is they have the same ethics and values that I have. So, like one of the things we do is our salespeople are paid a nice income, and there's no quota, and there's no bonus. So that means you do not get calls at the end of the quarter because somebody's trying to make their numbers, right? We don't do that kind of stuff at all. We treat you like you want to be treated because we're former DBAs, or currently still DBAs, right? So what's going on here? So again, I know I'm taking a little bit too much time, but let me show you real quickly on my browser. Let's see here if I can find it. Looks like Link overwrote the page that I had open, so let me pull it open one more time. So I went to my boss a few months ago, and I said, I'm thinking about taking my family on a vacation to Chicago, and I was wondering if you paid for one of my nights in Chicago, would you be cool with me speaking at the SQL Server user group there? And he said, yes, and I want you to speak at every SQL Server user group between Nashville and Chicago, going and coming. And I said, I love your enthusiasm, but that means it's not a vacation for me. But that's irrelevant. So what we're doing, I don't know if you've seen these blog posts I've been putting out, but we're doing it kind of like a rock tour, and it's all a riff on the vacation movies. Have you ever seen those with Chevy Chase and stuff? The first version I like better because it has the dog chain that was hanging off of the back of the Wally wagon. But I know we have some PETA activists in our membership. So, and there's the Wally Wagon on front. So it's all good fun. Grab one of those T-shirts, please, because I don't want to take any home. The other thing, though, is that it's not just me coming and speaking at these in-person events. One thing that we love about the community is that this is a very active group of people. So I don't know how many of you have come to these user group meetings on a regular basis, but we have this concept called SQL Family. And so the SQL Server community is really connected online through Twitter and LinkedIn and Facebook and things like that. And so it's kind of fun when you go to the big PASS Summit, because people are like high-fiving and giving bro hugs and all that kind of stuff, and they've never met in the real world before. They're like, oh my God, you're SQL Ninja 69. Ah, yeah, great to meet you. So traditionally, summer is kind of a low, quiet time. Everybody is taking vacation. And we thought, well, why don't we play on that and get SQL Family involved? So if you have a Twitter account or you're active on Facebook, do a tweet with SQL Vacation and sign up here. And every person that enters, if you do it on Facebook, you're entered into a raffle, and one out of 25 people wins. And we're giving away full licenses of our PE Pro product, which is $300 regularly. And we're also giving away very nice embroidered courier bags. So please, take part. And that's going all the way through the end of July. I'm wondering if this microphone isn't working either.
Test 1 2.
She's able to hear on link.
She can hear on link, okay. It doesn't sound great in here. Well, that sounds good. Or we could even turn off the mic here.
Do you want a Bob Barker?
I do not want to carry that around. Because I've got demos and things like that, so that won't be a good solution. All right, so let me pull this down. Just want to make you aware that it's something to just get the community involved in, and hope you participate, and we'll have a lot of fun. So the first one on our list today is 10 things every SQL developer should know. And again, let me make sure I've got everything turned on that I need. Well, it's advancing here on this screen, but not on that one. All right. We have a couple really, really good websites. If you don't read blogs, you're really missing out. Maybe you don't care about mastery of your chosen profession, but I think most of us do. Most of us want to get better. And so there's a few good blogs that you really should add to your list. One I always recommend, for example, is SQLskills.com, where Paul Randall and Kimberly Tripp and Jonathan Kayatz and all of that team blogs. SQLblog.com is another great one. Brent Ozar's website is great. And then this is another one, SQLperformance.com. And this is one that my company sponsors. We write really hardcore, in-depth articles about things like, what is the best way to bring two data sets together? What performs better? A join, a subquery, a cross supply, intersect, union. I mean, there's lots of different ways to bring data together. So we give you really empirical information about performance improvements. And every year we put out a best of ebook, normally $10 in the Kindle bookstore. If you will email me or ebooks at SQLSentry.com, we'll give those to you for free. They're not throwaway. I mean, they're not like 30-page ebooks if you've ever seen those before. These are, the smallest is 340 pages. So it's the real deal. A lot of great information. And each book has several exclusive articles that aren't on the web or anything. So please go ahead and get a hold of that. So things to be better about, skills that SQL people need. Part of this is the tooling, knowing the tooling really well. Part of it is knowing how SQL Server works. Part of it are our processes and our techniques. How do we approach solving problems, making our SQL Server perform really well? And if we apply these things together, this is going to make the people responsible for data in your shop much happier, much more cooperative, much more supportive people. How many of us here, primarily, our main daily job is writing code, SQL code perhaps, or some other kind of code? development of some kind. Okay. How many of us are primarily admins? We do DBA work. Okay. It's not. That's only about 60% of the attendees here. How many of us are maybe in BI or something like that? A couple. Okay. What else am I missing? Generalists, maybe you're a Windows person, you stumbled in the wrong class, you thought you were going to SharePoint. Anyone a manager here? Or you don't do anything? Okay, good. So I'm going to talk about techniques, but, code, but it's not all code. Some of this is how you approach the problem. And the first problem that I experienced as a burgeoning SQL developer was I was given an assignment to change some code that someone else had written that wasn't performing very well, and I was told to make this code faster. And so I had this big block of code, and I took a look at it, and I ran it to see how it performed. I had the stopwatch out. This was way back in the late 80s or early 90s, so there weren't a lot of tooling in those days. And so I saw how long it would run, and I checked to see what the result sets were, so I'd know what the data should look like. And then I came back and I looked at the code and I looked for opportunities for where I could improve some of the things that they were doing. And so I changed a few things, and I came back and I ran it again. And it ran a fraction of the time of that first run. I was like, oh, I'm a Transact SQL demigod. I'm so good. And one of the more senior guys in the office who years later, developed into a real mentor for me, he said, well, Kevin, how did you handle this? How did you handle the caches? Because back then, the only way to clear a cache in SQL Server was to restart SQL Server. And everybody in the building would have known if I'd done that. I said, what are these caches that you speak of? So what I hadn't realized was on the first time I ran that query, it interrogated the cache, the data cache, the plan cache, found that it didn't have the data it needed, went to the disk, spun those disks up, that took a while, loaded it all up in the cache, and answered my query. When I wrote another version of that query, it got the exact same data. Had a new plan, execution plan, but now it said, oh, I don't have to go to disk anymore. Got it right here in RAM. So the reason it was so much faster was because I was comparing apples to oranges. I was comparing an uncached data set to a cached data set, and I didn't even realize that. So as time went on, I realized, I came to understand that I needed to stop making these mistakes. So let me show you what my test harness looks like. All right. And I'm going to have to look over. This is something you may have saw struggling with a few minutes ago. I'm going to have to look over my shoulder to show you what's going on here. The first thing I always like to do, now this, for certain kinds of code, you can't get a whole holistic view of how much time it takes, if you have multiple batches. So I sometimes will use this starter bit of code here to capture the time that the start of the batch run begins. Then the next thing I do is I issue a checkpoint statement. Why would I checkpoint my little dev database? What's a checkpoint do?
Well, according to your comments, it flushes all 30 pages.
Thank you. Thank you. I have succeeded. You were the first person that actually said, well, in reading what you have on the slide here, yeah, so a lot of people don't seem to notice this. Yeah, what happens is whenever we change a page in the cache, that doesn't mean it's been changed in the database. SQL Server does that by its default behavior is to do that every time it issues a checkpoint, which you can do manually with the command, or you can wait till SQL Server does it itself, which is controlled by the recovery interval setting inside of the SD configure settings. And that's set to 1, meaning 1 minute. So every 1 minute, you're going to see a big I/O spike in your SQL Server. So what happens if I'm testing code and SQL Server decides to do a checkpoint right in the middle of a 23-second run? It's going to look really, really slow. And I'm going to get kind of erroneous results. So what I do is I issue a checkpoint before I test my code just to make sure I'm not going to have this happen in the meanwhile. Then, again, I don't do these two in production, and I don't do these two drop DBCC statements. I don't do those even on a dev server that's used by lots of different developers at the same time. But if I'm on my own personal workstation, which is how most of us work these days, what I like to do is I like to clear the cache, the plan cache and the buffer cache. So that first statement, DBCC drop clean buffers, that will clear out the data cache, all the indexes that have been loaded, all the tables that have been loaded. And then the second statement there, DBCC free prop cache, that clears out the entire plan cache where all the execution plans are stored. There's actually a dozen or more caches inside a SQL server. So you can also, there's one more statement you can use called DBCC free system cache, which will clear out those other things like hash buckets and sort caches and your extended event caches. I don't use that very often. You can be really selective with the free prop cache statement. You can use a parenthetical there, and you can say what the database ID is, just to clear up one database worth of plans from the cache. You can even put the plan handle in for a single specific SQL statement if you want to do that. But like I said, in my case, usually when I'm working, I've got my box, and I just need to clear it out for me. Does anybody work differently than that these days? You've got a dev box with lots of servers? I mean, lots of DBAs?
I need to get our own developmental integration development box.
Okay. But a few other hands went up too, so your mileage may vary. Don't do this when there's lots of other people on there. Maybe you don't have a big budget. You've got a server that's both production and dev, and they're just different databases, which I don't want to be there when it hits the fan. But yeah, you had some problems. I'm sorry? There's a window for you to jump out of, exactly. Right. So those are some things I like to do. Also, when I'm tuning code, I like to just have this. This is my harness. This is what I rig up my SQL statements in. And I'm an old school guy. I've been doing this for a long time. So there are GUIs to this kind of inner instrumentation, but I always like to keep track of set statistics I/O. This tells me a whole lot about what's going on I/O-wise in SQL Server, and then set statistics time. Now, each of these have their particular role when I'm doing queries, and they will. I cannot see a darn thing here, and they will. You know what? I don't even have a connection. I don't use them every time, all the time, but usually when I'm tuning code, I will use these at least when I'm looking around. So set commands stay on until you turn them off, which means they may annoy you, right? Because they're like, dang it, I forgot to turn it off. But if we have this on, and let's just run a simple query against a view in the AdventureWorks, if you come over to the messages, you'll notice you've got all kinds of additional information here that you don't get normally. So this is telling, let me zoom in a little bit on that. So we've got a work file. That's a spool out to TempDB. We've got a work table. That's a different kind of spool out to TempDB. We've got logical reads. We've got scans. Are scans a good thing?
Depends.
Thank you. That is the correct answer to every technology question. It depends. But all things being equal, probably not, right? This is a yellow flag. I want to find out why there's a scan going on. It's not a red flag. It's a yellow flag. This number, by the way, is also the number of 8K data pages. So if you want to know how much data that's actually affecting, you got to multiply that by 8K to see how much it actually is. But this is a good way to get a quick picture of what the I/O load of your particular query is. So this looks like a really simple query. Select star from a single object where it's between these two numbers. But in fact, it is a view that has an enormous amount of joins and things happening underneath it. It's a real pain in the rear. The physical reads one is your definite red flag. How much do I have to go to disk? And so that's one that I always want to look at and see if I can identify this as well. Let me turn this one off. Set statistics time, of course, does a little bit different. It just tells me about the time consumption of a particular query. I always like to know that too. So again, if we execute this, we'll see the results in that messages pane. So here's the CPU time, and right next to it's the elapsed time. One of the interesting things that can happen is that the CPU time can exceed the elapsed time. Elapsed time is the amount of time clicking on the clock. How is that possible? What would the CPU do to have more CPU time?
Multi-threaded.
Multiple threads, parallelism, right? You got 4 CPUs, and its elapsed time is 16 milliseconds, but the CPU time is 58. 16 on each of those, or more. Also, you can look at the execution plans as well. So, again, most people are used to looking at the graphic execution plans, which is mostly what we will use throughout today, but you can look at them textually as well. And again, like I said, I'm an old school user of SQL Server back before there were any execution, visual execution plans you could look at. Did I not click
You got an error on your last.
Did I get an error on this one down here?
Didn't like your exclamation point.
Oh, I've got an exclamation point. Must have fat fingered that somewhere. Thank you for catching that. All right, so that worked. So now if we look at this, we see the textual output of what the execution point. And so now we can begin to see, for example, we've got these hash matches. Again, it's small, you might not be able to see that. A hash join is one of 3 algorithms that SQL Server will use to solve a join, and that always results in an intermediate work table in TempDB. So that might be either that work table or work file that we saw in the I/O output. But again, we'll look at this in the graphic way in just a moment. Let me turn that off here. All right. So that's the first thing you need, is to make sure you're taking steps that are going to give you consistent and reliable results inside your SQL Server. Now, let's see. Next thing you need to learn, I've already touched on it. You got to know the basics of reading execution plans. If you're going to ever tune somebody's code, you can do a little bit of help by looking at the SQL statement and saying, oh, I see some worst practices in use here. But if you want to be really good at this, you need to know how to read the basics of execution plans. And I'll show you that in a moment. Now, one of the things that Julie pointed out, thank you, Julie, we have a free tool called Plan Explorer that makes this really easy. And it is so free, we don't even take email addresses, okay? You'll never get spam because you downloaded this and used it. So there's no reason not to get this tool right away. It's really, really good. You can also watch things as they happen in Profiler or in extended events. And the whole process of tuning queries is to try alternative ways to get the same result set so that it will provoke in SQL Server a new execution plan that may be superior. SQL Server uses what's called a cost-based optimizer. Okay? Anything SQL Server does, it assigns a cost to it. And one of the weird things, one of the underlying assumptions of the cost-based optimizer is that human beings are jerks. And now how would an optimizer assume that? Well, what it is SQL Server attempts to give you not the best execution plan, it attempts to give you the optimal execution plan. What's the difference?
The best execution plan can take a long time.
The best execution plan can take a long time. So SQL Server assumes we're all impatient jerks pounding the podium. When are you going to give me that execution plan? And so it's going to try to deliver you a good enough plan within a very short period of time. Usually 5 seconds is where it says, I'm just going to give you whatever I've got. It varies. And the more advanced the version of SQL Server, the more time and the more variables there are into how it will do that. But the assumption SQL Server makes is whoever's on the other side is impatient and mean, it's going to hurt me. So I better give it to him right away. So if you don't know execution plans already, the good news is there's an easy way to start. And the easy way to start is to look for the bad, not to actually learn what's good, better, best, but just to be able to identify what's typically bad or something to be concerned about inside a SQL Server. And those, in general, when we look at the different operators, we are going to look for lookups, row ID lookups, key lookups, and in older versions of SQL Server would be bookmark lookups. We're going to look for lookup operations. Scams are something we should always investigate. They may be the best way to resolve what you have asked for, but we need to make sure that's the case. And then spools. Spools are usually very resource intensive. That means SQL Server is having to produce an intermediate result set over to TempDB. And no matter how many users, no matter how many databases we have on the SQL Server, we only have one TempDB. And it's usually the most heavily thrashed of all the databases out there. So if we can avoid spooling to TempDB, that's usually going to be to our advantage. Now, that last one I I kept up there because parallelism was a boogeyman for a long time when SQL Server 2005 rolled out and could do parallelized operations. Over time, it has gotten to be less of a big deal because CPUs have grown in number on servers, right? So when you only had SMP servers, you had 2 and 4 CPUs, and that was a big deal. Parallelism operations could wind up being a big problem. But in fact, nowadays, we just want to make sure that they're not a big problem. So it's not always a bad thing when you see that. Now, there's some other red flags that are not in the operation, the plan, the query plan. For example, there's 2 ways to pull a execution plan. There's an estimated plan, and then there's the actual plan. So with an estimated plan, SQL Server hasn't executed it at all. It's just telling you what it thinks it will do. On the other hand, we have the actual plan, which is SQL Server went and did it. It got the data you asked for. And here's how I did it. You know, it's the full behind-the-scenes look at all of the steps that it took. If there is a big discrepancy between the two, this is a huge warning sign. Does anyone know what it tells us is wrong?
Statistics.
Right. That's correct. Your index statistics are very stale. They're not right. They don't tell SQL Server enough of what it needs to know to be able to find that data. High physical reads is often a problem, particularly on a dev box. Okay, if you're in production and let's say you've got a 2 terabyte database and there's only 64 gig of RAM on that server, mathematically speaking, there's no way you're going to get all that data up into the cache, right? You just never will. So SQL Server will have to be reading physically all the time, back and forth. But if you are sitting there on your dev box and you're the only person developing on it and you have high physical reads, that is a good indication this is poorly coded, because you should not have to contend with lots of other users querying their tables up into the cache too. There's alarms of different kinds. There's missing index alarms. There's missing statistics alarms. So keep those in mind. And I have a whole slide we're going to talk about implicit data type conversion. All right. Now, here's a secret ingredient of this recipe, of this presentation. You're not going to hear from anybody else, except maybe my colleague Aaron Bertrand. One of the big challenges is one I just mentioned. We've got a 4 terabyte database. I have my laptop that has, it's a big laptop. Mine right here, 8 CPUs, 32 gigabytes of RAM, half a terabyte of disk space. That's stout for a laptop. It is nowhere near as big as what the production database looks like. But there are ways we can fake SQL Server so that it will produce the exact same execution plans as what we get to production. So I'm going to show you how to do this. First thing we have to do is we have to build a clone. Okay? So let's go back over to Management Studio. We have to build a database clone. Now, I've seen people who have a database that is a manageable size compared to what we have. The production database is manageable size. It's 20 gigabytes, and our dev box can handle something like that. But it's, believe it or not, you're still not going to get the same execution plans on your laptop as you will in production, because production has a lot more CPUs, it has a lot more memory, so SQL Server will make very different choices. But what you want to do as a first step is you want to create that clone. So we find the database that we want to create on our laptop, and we're going to script it out rather than do like a backup and recover it. And most of the time, we're going to choose the script database option. That's not the right choice. Again, Microsoft has hidden this a little bit deeper. You have to go to Tasks, and then there's Generate Scripts option. Okay? We pull that up, and you can do this however you want. For example, you may not care about, views or something like that, but let's go ahead and say we're going to script out all the options, all the different objects in the database, and then again, it's hidden once more. What we're going to do is we're going to say, okay, I know there's no data in this database yet, but I want to copy not only the tables and all the data, I want to copy the indexes, and don't know if you can see that, this says script statistics. We're going to get not just the statistics, we're going to get statistics and histograms. So in case you don't know what a histogram is, so the statistics is a raw number that a SQL Server looks at so it can make cardinality estimates. Cardinality estimates is a fancy way of saying take a guess at the number of records that will be answered by, for a particular search argument. So let's say the customer table, and the customer table has first name and last name. And it's going to, and we're going to do a search based on the last name of K, Kellenberger or Kline, right? Well, it's going to look at that and it says, well, just all things being equal, I think this index has a 72% selectivity. So 72% of the time I'm going to be able to do a C directly to the record that I want. That's the statistics. It's a simple number. It's not very complex. The histogram is a statistical model that's much more sophisticated. So what that does is for each bucket, it produces its own smaller set of statistics. So SQL Server, in the case of that last name column, might have a bucket of 2 starting letters of the last name. So A and B together, C and D together, D and E together. And it might say 6% chance of hitting an A or B, 8% chance of hitting C or D, 3% chance of hitting E or F. And then we get all the way over to like R and S, lots of names with R, starting with R and S. That's a 17% chance. So it looks like this wavy kind of thing, and each one is got its own probability of answering whatever it is you're looking for. And we're telling SQL Server to take those from production and put those here into dev. So even if we only have 20 records in there, it will make the same query execution plan choices as it does in production. Okay? So let me show you a little bit more about that. I'm not going to generate. It only takes a few minutes to generate, but I'm not going to do it here because I've already got it pulled up. When you export it, you want to modify it. And the first thing you want to do is right here. You want to tell SQL Server not to update or create new statistics because we're faking it. We don't want you to change the statistics that we've gotten from production. Keep it just like that. So that's one thing you want to add in is set auto-create statistics off and auto-update statistics off. But then as we look at this file, we start to see, well, here's some routine stuff. Here's creating some functions. It'll create tables. It'll create the views. It'll alter them to change some of the properties. But then when we go real far down, we start to see some really strange things that you probably have never seen before. There's the alter table statements. Look at these. I'm going to create some statistics. And this is the one you probably have never seen before, with stat stream. And it's strange looking. Hexadecimal. And this is the actual values of what production has stored into that in a hash inside of the metadata. This is telling SQL Server exactly how the statistics work in the production database. Now, in my case, I also want to have some data that will answer every query I write. So I wrote a quick and dirty little script here. This particular script is very quick and very dirty. Somebody smart will come along and do a much better version of this. What this one does is it just goes through all the tables in a database, and it BCP, that's the old data import and export utility. A lot of people have never even seen it. But it starts at record number 1. That means first record is 1. Last record I want you to BCP out is number 500. So you can actually come in here and you could say, get 500 records from every table. BCP's amount to path the limited file and reverse it, BCP them back in. You could say 5,000. You could say 50,000. How much space do you have on your dev box? You want it to be a 2 gigabyte database? Change this number. Fill it up to that point and continue to work accordingly. Again, it doesn't take into account foreign key constraints or dependencies between tables. You've got to work that out. So. But in my case, just having 12 or 20 records to answer a query is good enough for me to make sure I'm getting the right execution. Now, another thing that some smart people have asked me is, well, I already have a dev database that is really, really well honed. I mean, we've been working with it for years. The QA team has put a lot of data in there so that we always get, well, you know what? Why don't you just skip all the database creation part and just copy the update statistics statements and make your statistics just like what they are in production. You don't even have to refresh the database, right? So now you know you're 90%, I shouldn't say 90, you're more like 70% of the way of getting an exact replica
of the execution plans that SQL Server will always give you in production. Now keep in mind, it's not the same speed, because it's not the same amount of records that it's got to go through. So you're not measuring clock time, you're looking for the best execution plan. The other thing that takes us the other 30% of the way is SQL Server uses those cardinality estimates, the statistics, the histograms, to generate the execution plans. The other two things that it uses is the amount of memory you have and the number of CPUs you have. And we can also face SQL Server out there. So let me show you that. We get to use a really cool option. Why did it not do that? Oh, it is. That is 150%. If you're getting old like me, 150% isn't enough anymore. My goodness, I'm like, I need 200%. Okay, so we're going to turn on the execution plan here. One right here. And let's just take a look at this particular plan.
I think you turned it off.
I just turned it off, didn't I? Yeah, thank you. So we're going to look at this particular query, and again, I need to attach. That's the problem with you get your demos all set up and you queue it up, and then you close the laptop and come into the office, and then nothing's connected. All right, so let's execute this and see what we get. So here's our execution plan tab. Now, if you haven't read execution plans before, start at the right and work your way left. So SQL Server has this one particular step, a clustered index scan. It costs 4%. The next step is a sort operation, costs 18%. So that you might even see people making recommendations of, oh, you've got a subquery that's got a, somehow does an order by or something like that. Like, why not do no order by the final result? Yes, question?
If your execution plan is 10 pages, is it top to bottom or bottom to top? Right.
Okay, so the question was, if your execution plan is 10 pages, is it top to bottom or bottom to top? So what happens is, logically, SQL Server actually starts at the upper right corner. And these other things merge into it. So it starts at the upper right, processes to here, and then says, I need other stuff. And then it pulls the next one in, and then they continue together. Okay. So this has got two strings because it's doing a two-table join. The order header and the order details. 73% of the cost is on this one step for the clustered index. All right. Now keep in mind, none of this is parallelized. SQL Server would tell you if the step was parallelized with a little round circle here with two arrows on it. Okay. So now what we're going to do is we're going to take SQL Server out. We're going to tell it that this little server of mine is as big as production. And to do that, we're going to use the DBCC optimizer what if statement. I remember when I first blogged about this, Paul Randall, a friend of mine who used to be the head of the storage engine team at Microsoft, and he has a patent on DBCC. He emailed me and said, how the hell do you know about this and I don't know about this? And I said, I don't know actually. But we're going to tell it that we have 64 CPUs and we have a terabyte of RAM. We're going to lie. Now, let's go ahead and execute that again. See what we get. Think it's going to be the same? I wouldn't be showing you this if it wasn't. So now look at that. See this step right here? Parallelism. It's gathering all the streams. So even though this only has 8 CPUs, it acted like it had 64. It spawned 64 threads. Just took more time to actually process it. It actually went out and did this. And if you notice, it's very hard to see, but there is a little tiny circle with 2 arrows in the corner of each of those different operations. So it's fully parallelized, this whole thing. And we can see that it's actually shifted a lot of the work to the step that gathers all of those streams back together. This is 11% of the total amount of work. We can also use this to go the other direction. So a real common thing we see these days is somebody buys state-of-the-art new hardware, 128 CPUs, full terabyte of RAM, and we're going to put 100 VMs on there, many of which are only going to have 1 CPU and 1 gigabyte of RAM because it's keeping some SQL Server 7.0 application we wrote 20 years ago, and it works just fine. Customers don't want it to change. So we're going to keep it alive. So we can go the other direction too. Okay, now remember the form we had just a moment ago where it said compute scalar and it said nested loop. Now this one has compute scalar parallelism and a nested loop. Let's go the other direction and tell SQL Server we don't have as much as what we had before. Tell it we only have one CPU. Now let's execute. Look at this. It didn't even choose. The last two steps there are not anywhere like what they were before. This is a merge join and a sort operation. Merge join is much more intensive. Usually it results in spooling a table out to its empty V. Okay? So we thought because I have only one result set, I can't juggle two very well. I better spool it and save it. And of course you see there's no parallelism either at all. And whenever you're done, you can just come back in and use this reset all to put it back to normal. It's not server-wide, it's only the context is the connection that is running this, as far as it goes. Okay? So by doing those three things together, creating a clone database that has the statistics and histograms from production, copying down enough data to give you decent results as to check the accuracy, but not so much that it overwhelms your storage, and then using DBCC Optimizer What If, you can create, absolutely, you can guarantee that you have identical execution plans to what you have in production. Any? All right. Another one? Now, another thing I find developers don't know as much is, well, I shouldn't say developers, everybody I run into. There's not a lot of people who realize exactly how the plan cache works. So they have, this is a fundamental that we all need to know. What happens is every time we compile any piece of code, ad hoc or compiled, stored procedures or whatever, SQL Server creates two numbers. The first one is a complexity value, and the second one is a complexity counter. Countdown timer, if you will. About every minute or so, again, it depends, there's a little asterisk at the end of that statement. There are other reasons that the lazy writer can be invoked. But you can count on the lazy writer to wake up about every minute. In this case, this guy's my lazy writer. And I don't even know why I use a pronoun. It's not a guy. It's a thing. But lazy writer takes a look around. And based on where I've been since last time, what's happened since last time, if any of the code in the plan cache has not been used, I decrement the countdown timer by 1. This is the state of the art from my animation skills. I hope I get some love from you guys. So again, it goes away for about a minute, wakes up, comes back, takes another look around, and he begins to decrement these values if no one is using them. Again, that's what an LRUK algorithm is. LRU stands for least recently used. So anything that hasn't been used recently, I want to get rid of. But the -K means I'm going to make an allowance for very complex things. The more complex it is, the more chances I want to give it to stay alive in the cache. So what do you think lazy writer's going to do when these guys reach 0? You already know what the correct answer is, right? So, I didn't figure this out until, gosh, mid-90s, when all the big database vendors were publishing TPC benchmarks. One of the things about reading the TPC benchmarks is that they have to declare all the ways in which they cheat and to get these great numbers. And in there I saw a command line switch I'd never seen before for SQL Server, which turned off the ghost cleanup process. I didn't even know what the hell's a ghost cleanup process. Well, as it turns out, when one of these hits 0, SQL Server doesn't delete it or clear it out of the cache. What it does is it ghosts it. So what that means is there's another process, another thread called the ghost cleanup process. And it's always on the lookout. Anytime one of these becomes ghosted and there is memory pressure, I get rid of it right away. So something else can step in and use that place in memory. But if there's no memory pressure, why be so hasty? Somebody else might come along and need that code too. So I'm going to go ahead and refresh those that I reuse and keep them alive, or if they've been ghosted and there's no memory pressure, I'll keep those alive, even if they count down to 0 and below, okay? But occasionally somebody will come along and use one of these, and that means the countdown timer is refreshed. The more complex and big it is, the bigger its number, the longer it gets to stay in cache longer. That's one of the big reasons why you'll hear people encouraging you to write specialized code. I've seen developers who are like, well, I've heard I should do code reuse. Yeah, for C#, but not for SQL. You write specialized code for SQL. So for those developers, I've had to kind of show them this stuff in detail because they have written one stored procedure that does inserts and updates and delete and all those kind of things depending on what parameters you pass to it. And it's like, no, you don't do that. Because you're bloating the cache and you're causing all these reasons to keep it fresh in the cache, when in fact it could be 3 or 4 different stored procedures that keeps your cache a lot smaller. What about the buffer, the data buffer cache? What's different about it from the plan cache? The short answer is not much. Works pretty much the same way. The longer answer is about everything, almost everything. It's enormously different in its nuances. So it's like, it's based on 3 or 4 different things. Like, is it a heap or does it have a clustered index? Yes or no? How big is it? How many non-clustered indexes does it have? How big are they? And so based on each of those, it has all kinds of choices about how long it keeps things fresh and in the cache. All right. Now, another big mistake that I made myself, I see happen all the time, is that I'm causing SQL Server to recompile without even knowing it. You know, normally what happens with SQL Server is it takes a look to see if some code that you have written, you've invoked it. Is it in cache? Can I reuse a version of that maybe I just changed the search argument and it's going to work for me? If I can reuse it, I will, if it's not in memory, I'll compile it, optimize it, and so forth, go through this whole process. But if it is, I can reuse it and just execute. If it's not, then I have to go to this step over here of grabbing all the metadata, I have to compile it, I have to optimize it, and then I execute it. Well, a lot of us don't realize that the way we write our code can tell SQL Server, execute, uh-oh, I'm not sure what I'm doing here, I better go back up and recompile. And now I get a little further, oh, something else, better recompile. There's a lot of reasons why our code will recompile. Maybe because we asked it to. It was paged out of cache, as I showed you, naturally. And then there's some other things that can cause it to happen, like we change the schema. You add a column to a table, SQL Server is going to say, for a piece of code that addresses that table in the cache, it's going to say, I don't know if this code actually is going to hit that new column that's been added, so we better file a new plan. But the big one is the second from the bottom. And let me show you what happens there. When we have a piece of code, say a stored procedure, it could be a batch, it doesn't even have to be inside of a procedure or function. Anytime we interleave DDL statements, that's the data dictionary language part of SQL, alter, drop, create statements. Anytime we interleave those with DML statements, insert, update, delete, select, merge, SQL Server says, I'm not sure what I've got here. I better recompile to find out what I've got. So I had a friend who called me over. He's at a practice management company. They make, practice management software for doctors, OBGYNs. And they were having some real performance problems. And I took a look at it, and there's some perfmon counters you can look at in SQL Server that tell you the number of compiles as a ratio to the number of recompiles. And they were averaging 18 to 1. It compiled one time, it has to be recompiled 18 times before it finished. Because what would happen is, in their reporting module, their developers were a little bit lazy. And so what the first person who wrote the code took the first pass at it, said, create a temporary table. Now insert into that temporary table all the data we're going to use to munge this report. And then a few months later, somebody said, oh, you know what, we got to change this report, we're going to put subtotals in. So we'd say alter table. Now let's update and put values in those subtotals. And then somebody else came along a month after that and said, oh, let's alter that table again and add another column. We're going to put some values in those columns with an update statement. Every time SQL Server got to those, it would have to restart that code again. You have to recompile the code. Yes?
You mean recompile, does it go all the way back up to the top of the batch, I guess, the sort procedure batch?
Right. So the question is, how far back does it have to go? And it depends on the version. So 2005 and 2008, all the way back. 2008, one of the service packs, and R2 and later, it goes back to where it left off. So instead of going all the way back here, it'll come back to this point and go to this point and then go. So you're still recycling through a lot of code, but not as much after that fix.
So it would create the store procedure, and it would compile a plan at the time that you would create it, then you would execute it, and then it could recompile what it already had compiled because of...
Yeah, basically what it does is it says, okay, I got to this part, and now I've got some temporary statistics I've created for this temp table. Uh-oh, we've changed it. Oh, now there's more data in there.
So it can't trust the statistics.
They can't trust the statistics, right?
Okay.
Yep, that's
because
what
something
it is.
has changed to
Okay.
the metadata.
Exactly.
Okay.
So there are several different ways you can solve this problem. For example, you could just put all the DML or DDL statements up at the top. Personally, that's still kind of lazy, you know, because it's like if you've got a create table statement and you're altering the table, why not just change the create table statement to have the right columns to begin with? You know, have the developer, you know, I tease the guys, it's like, you know, don't you read the code that other people write? And I'm like, hell no, we don't. I'm like, well, maybe you should, you know. See what the original create statement says, and, you know, put a comma and add another column to it in the data type and so forth. That's one way to fix it. Another thing you could do would be, it's the interleaving that's the problem. So you can have all of these DML statements, and you could have a exact my stored procedure for the insert, right? So each of the DML statements, you could have a separate stored procedure, which would have its own execution plan, and they would not recompile each time. And I don't actually recommend that you ever use temporary variables. Don't like them very much, except in these kind of situations, because they do not provoke this problem.
But Kevin,
Yes.
there's so many other terrible problems with them. What are you talking about?
Sorry. Oh, yeah, with temporary variables?
Yeah, because there's no statistics on them.
Oh, yeah.
Row 1.
That's actually slide 10.
Right.
Good point.
So just say you don't recommend temporary variables.
Yes, I do.
Except for what they were intended
I
for.
don't recommend temporary variables. Now, here's another one. This is a big problem. Again, Microsoft has done a great job of marketing SQL Server as the easiest system to get up and running and to maintain. The problem is the defaults in SQL Server are there's two big problems with the defaults. One is they never change them. So if a particular setting was introduced in SQL Server 7, they took a guess at what would be a good default for it in 1998. And it stayed the same since 1998, right? Almost 20 years ago. That's the first problem. And the second problem is they set the defaults for maximum maintainability, but not for maximum performance. Okay? And this is one example. A cursor, believe it or not, according to the ANSI standard, a cursor can go both up and down. Not necessarily just read records forward, but all I ever want to do is read records going downward. A cursor can also be addressable by me multiple times. That's why we give it a name, so I can come back to it and call it again or call it from another thread under my provisioning. But we don't need that. I don't know anybody who uses that capability. That's called global versus local. I only use local cursors. Another thing is the number of records that we move at a time. So I always go one record at a time. But there's a setting called ABS, so you can say absolute. You can say absolute 5, and it will go every 5th record. Or you can say ABS minus 5, and it will go up 5 records as that results in. Anyone ever do that? Nobody raised their hand. Okay. I'm afraid somebody's going to blow my whole thesis here. And another thing that it does is that it is also read-writable. And I almost never write to my cursors. I only read from them. So I just want to go forward one record at a time. And the defaults are not set for that. Again, let me show you in demo here. This is issue 3. And I can't see a darn thing. Is that 150?
Thank you. So I'm going to just turn off the settings that. Simple cursor. I'm going to join a bunch of values together, process through them. It takes a little bit. Of course, at the end we have to deallocate, get back the loss, memory space to the side. And I have to connect. So, again, what's happening is SQL Server, the Microsoft development team calls it scaffolding. All the stuff that is around the object that supports its activities and behaviors. One of the things that Kathy alluded to that's great about temporary tables is they have all the scaffolding of regular tables, which means when you create a temp table, it will start to collect statistics on the search arguments you use to interrogate your temp table. That's extra stuff, extra overhead, in a good way. But in this case, it took 16 seconds to process this cursor because we allowed it to be global, absolute, read-writable, scrolling upward and downward. So 16 seconds for that to support all that additional scaffolding. Here's the trick. We want to go local and fast forward, which means one record at a time, only forward, and only read. Okay? You need to clear your cache. You would clear my cache, yes, thank you. I'm not going to though. I've done this enough times to know this. So typically this takes, let's see, 6 seconds. That's exactly what it takes on this machine all the time. So 16 seconds versus 6 seconds to get exactly the same behavior we always want, right? That's a good way to write your cursors. You'll get much better performance that way. Now there are situations where you might want to use read-writable, updatable cursors and knock yourself out. But I'm not a big fan of those kind of cursors either, because usually you should be using separate process operations anyway. All right. Now, at the top of the hour, it's actually a moment or two. From one page to the next. That's what a clustered index does. And then we create on top of that non-clustered indexes. And so what that is a root page with various numbers of intermediate levels that get all the way down to the root page. So the idea is, again, if we were going to look up everybody whose last name began with B in the customer database, instead of reading this whole table, I now only have to read 3 AK databases. I read the root page, an intermediate page, and that final bottom level page. That's great. That's very, very useful for reads. Reads is the operative word. What about if I have lots of writes? So don't forget, there's a big, big difference between our read operations and the workload which has heavy write operations. A friend of mine tells a hilarious story, hilarious in the sense of shaking your head in amazement, of an organization that had a very robust, very money-making kind of application. It only had a couple dozen tables in it. And one of the tables was hit by tons of OLTP, right? It was the one that customers were doing their orders against, basically. That's where they were all recorded. But management also used it to do frequent reports, who's the most aggressive salesperson, or who's falling behind, that sort of thing. And it was getting slower and slower and slower. And so they called in this friend of mine to do some troubleshooting on it. He took a look at the table, which only had, again, it only had 20 to 30 columns in it, and it had 170 indexes, non-clustered indexes. And he tried to be diplomatic and say, who's the idiot? Tell me your indexing strategy. How do you do this? So there's 2 DBAs there, and they said, well, what we do is we'll take a query that's not performing well, and we'll take it over to the dev server, and we'll run it through the database tuning advisor. And it gives us an index recommendation. He said, okay, and then what do you do? And he says, well, we apply it in production. He's like, at what point do you apply that in development? They're like, yeah, that sounds like a good idea. So they never put those indexes that were being recommended in dev. And in fact, it was recommending the same indexes every single time. And they never even read the output. So there were columns in there that had like 40, 50 indexes on them. And so every time an insert was made, how many pointers have to be updated to that particular column? Every single index that points to it, right? So that's an extreme story, but don't forget, indexes speed up reads, but they slow down write operations because their values have to be updated in correlation to those leaf level pages in the index. So know your workload. If you have a mixed workload, one of the first recommendations of the performance tuning people will tell you is to separate your workloads. Your read heavy stuff, separate it from your write heavy stuff, you know? If you've got a application that is both used for all your data entry and all the management are doing reporting off of that, bad idea. I mean, it's not horrible. And a lot of times our hardware is overpowered and can handle it. But if you want a big performance improvement on any of your relational databases, you specialize the workload. All right. So again, moving a little bit faster. This is another one that's really interesting too. A lot of people have learned the lesson that if you put let's say you've got a select statement with a where clause, where employee name equals such and such. But if you put a function on the column, it breaks any indexes that are on there because SQL Server says, I can't deterministically tell what the values are in here, so I'm not going to use an index on that column. What folks don't realize, though, is that there are data type compatibility issues. So there's lots of data types that look like they are compatible, text to text, numbers to numbers, but they're not compatible. For example, if you have an integer column and you're converting it, you're inserting or selecting from a table that has number values. That's, you know, number 9,2 or decimal 9,2 or money. What happens there? Integer is not compatible with those data types. So SQL Server behind the scenes puts a cast function on it. It's a function on your indexed column. It means we can't use an index anymore. It also has to use some extra CPU too. Right? What about varchar, variable character, right? Varchar max. Same thing, isn't it? No, it's a special flag. SQL Server says this could be practically a blob. I can't tell for sure that it's actually going to be variable character. Var binary 5, var binary max. Compatible? Actually not. Does a cast on it. How about varchar and in varchar? Got varchar, and both of them have varchar. Well, no, in varchar is Unicode. What is it? 4 bits per digit you give it, and varchar is 2. Completely incompatible. One of the big problems with that is that most of the ORMs, like if you use Entity Framework, or especially in Hibernate, is really bad about it. If you put text into any of your queries in Hibernate, it always chooses in varchar. Always. So what's happening behind the scenes is implicit conversion. Now, again, running behind. So I'm not going to show you all of the examples that I was going to show, but what I will show you is that there are 2 really great scripts you should add to your toolkit. Pull those up. One is by Jonathan Kahayas, and the other is by a blogger and writer named Ian Sturt. So Jonathan has a nice script that will look at your plan cache and anything that has implicit converts happening inside of the active plan cache, it will actually tell you what those are. Now, I can't guarantee I'm going to have any in here because I haven't really done any work, but let's see. Probably won't have it. Don't run this in production, by the way, until you've tried it a time or two in dev, because it's looking at every bit of the data in the plan cache, and so it can take a while to run. So it didn't find anything in this case. And I think this particular one is scoped by database, so I might even opt to switch databases. But the good news is for this particular script, it will tell you if Like, let's say you've got packaged apps. How many of us have bought something from a vendor? Those things are crap. You know, I talked to a friend of mine who's a security expert. He's like, okay, so our security team, actually, our front office team bought an application that controls the badges, you know, scan to come in and out of the building and what rooms you can go to. That same password is in plain text, and it's password, and it's packaged app. The development team insisted on it. This is the only way it will work, right? It's like, it's a security application. So I'm a skeptic of that kind of stuff. The other cool tool that is in here is from a guy named Ian Stirk, and he has written a really good book at Manning Press, DMVs from Any Angle or something like that. What this one does, let me actually go to a different database. SDB. And what this one does is it looks at all of the objects in your database, and it looks to see if two objects have the same, a data type of the same name, but they have different data types one from another. So that's kind of getting a heads up on how likely this database is to experience problems. So if you've got a table that's got customers, and the sales table also has a customer reference, and it's a different data type, that would be pretty worthwhile knowing, right? So that's another little script that you can use that is quite useful. All right, implicit converts. That's a big deal. It's one of the things you want to watch out. Okay, we're going to wrap up in just 2 minutes. Right. Temporary structures. This is something that Kathy was pointing out a moment ago. The big choice typically is between temporary tables and table variables. And table variables are useful in certain limited circumstances. But there was a period of time when lots of people were using temp variables, A, because they were new, and B, because there was this kind of myth running around that it was only instantiated in memory, which is absolutely not true. They are instantiated in TempDB just like temporary tables are. They have some benefits. They have a little bit of metadata overhead that's left, so they're a little bit easier for SQL Server to handle in that case. They avoid that recompiling problem. So there's a couple uses where they're pretty good, but even then, there's some caveats. You should not expect to put a lot of rows in there. Like, I don't ever use a temp variable for more than 1,000 rows. And again, it's one of those things where the primary problem is SQL Server, when it looks at a temp variable, it always assumes that it will only return one row. Whereas with the temporary tables, it thinks of them pretty much mostly like a regular table. Locking is a little bit different on a temporary temporary table, but pretty much the same. And so it has a little bit lower overhead for that. Again, not enough time to dive into this in great detail, but something to think about. The last one I want to show you in demo, and these are things that happen all the time that cause us to throw away 30% of the RAM we have on our servers. First of all, I've already talked about why it's so important to specialize your code. Do not write general purpose reusable code that does 7 different things. Way better to create 7 different pieces of code, because SQL Server will load those in and out of the cache as it needs. Another thing, and this is one of the things I don't know if I can say it was a persuasive argument, but like in my team, you know, I kind of insist on code standards, and I had people on my team who did not like my code standards. I'm not telling you have to use my code standards, but what I am telling you is you need to use somebody's code standards. Let's see here, that's 150. All right, so let's clear the cache. Show you this example. There we go. So I'm going to skip this example. Let's execute a very simple query. Oh, I have it in here. I'm going to select, I'm just going to say, does a record exist in the sales order ID? And we know it does, right? I don't course, I'm not connected, so got an error. Okay, to VentureWorks. Now exit. So here's the result set from that. Let's check and see how many of those we have in the cache. Of course, I just cleared the cache, so I should have only one result set. And I don't know if you can see this from the back, but this is the size of the execution plan in bytes, 32,768. Literally 32K in size. Now, don't forget, this was a tiny query. That's not very big, is it? Nuts, but it's 32K. Now, we're going to change this one tiny bit. We're just going to put a line in it. This is how I like it. I like all your keywords to start on a new line. Okay? I get cursed for this by certain members of my team. Again, here's our result set. Now, no reason at all that SQL Server should not be able to find and reuse the execution plan, right? So let's see how many are in the cache. Oh, there's 2 in the cache. I just thrown away 32K RAM. So there's a what about if I fat finger it and I've got one extra space in there? Certainly SQL Server's not going to count that against me, is it? I mean, smart enough to know that that's all white space and, oh, sorry. Well, what about if I don't use camel case? Up here I capitalize sales and order. So here I'm just going to put all my object names in lowercase. Surely you can see that is, no? Okay, you can't see that, right? What if I'm going all lowercase right here?
You just made all the development team that really hate all DBA.
Well, now I've got 5 in the cache. Here's what happens behind the scenes. The SQL Server takes a query to turn it into machine-readable code that it can execute. It creates a hash based on the binary values of everything you've typed. A binary uppercase A is different than a binary lowercase a, right? 2 spaces, binary speaking, is different than 1 space. So it says, I got to create a separate plan for each of these things that you're throwing at me. Even though a human being knows the difference, computers are only high-speed idiots. They just do what we tell them as fast as they can, which is really fast, right? But they just, and I can't tell the difference between these 2 things. So, yeah, your dev team may, you might have one person over here who loves Hungarian notation or the camel case, another person who doesn't. You guys should really standardize. And it doesn't have to be mine. If you all agree on it together, that's cool. But as long as it's the same thing, you will get much, much better plan cache reuse and avoid bloating that plan cache. For those of you who know about these things, can we tune how much memory SQL Server gets in the plan cache? Can we tell it how much memory it can have? You can tell it min and max memory total. That's it. That was one of the things I missed. I've been 6 years on Oracle, and I go to SQL Server, and I said, how come I can't tune the individual areas of cache? And they're like, yeah, that's funny. You can't do that on SQL Server. It's a philosophy. It's a mindset, right? Like, you go to Europe, 85% of the people over there drive stick shifts. And you come to the USA, 85% of people over here buy stick shifts, or they'll never buy a stick shift. They only drive automatic. In fact, I told my wife when I was trying to buy a car for my 16, I was like, we should totally get her a stick shift because it's better gas mileage and you can control the machine better, get back closer to the red line. She's like, only a man would think of it. And I said, well, and it's also got the best safety system in the world, security system in the world. And she says, what's that? I said, 85% of the people out there can't drive these things, so nobody will ever steal it. Her boyfriend won't even be able to steal it. Same thing here with, Oracle is the stick shift of the database world. And SQL Server is the Camry, because we've got our big gulp and our cell phone, and we're steering with our knee, and we're like, and I got to be able to open the window at the same time. So SQL Server is all about ease of use. Oracle is about tuning the machine maximum amount. All right. So we're out of time on this demo, and I've gone way over. Understand how SQL Server works, right? This the key to getting the most out of SQL Server that we can get. And those particular things are going to be the ones that are really, really going to help you go from being good enough to being the best person on your team at SQL. Pretty impressive difference what this stuff can make. We have a video of this on SQLSentry.tv. You can see this again. It's a variation of this, but it's essentially the same thing. There's also 10 hours of additional query tuning advice on there.